All right, here is our chromatography lab, and it's going to try to get this adjusted so you can see it. And what I have right here, so I'm going to do a little introduction here and show you what's going on, and then we'll go back and kind of work backwards and talk about it with a screen share. So what I have here is water, acetone, water, and acetone. I have about 1 centimeter in each cup, not very much. And then I have these strips of paper. I don't know if you can see those very well. We'll kind of show those. And they have a black dot and a green dot from either Sharpie markers or Mr. Sketch markers. And we'll go through that a little bit more closely. The acetone containers are already starting to react with the container. That's a whole nother thing dealing with intermolecular forces where the water and the plastic containers are not having any reaction and they look crystal clear. So what I'm going to do is I'm going to just take this strip and put it in here, and notice I don't want it to fall in and be surrounded. I want it to be below. There's these little dots, and I want the water to go up. Don't go up to the dot level, okay? So what I'm going to do is put that in, and you might end up turning these around at some point. I'll put one in here, and I want to get it down to the bottom. But standing up there, it likes to slide back. Okay, it never works quite like you like that. I'll put one here, and I'll put one here. Okay, and essentially what I'm going to do is cover these, keep a nice vapor pressure in there, nice moist environment. And so I got to separate these out just a little bit, get these watch glasses on, cover it, and then I'm going to let this go. We're going to kind of see what happens to this in a little bit, and you might be able to see the water is starting to rise up in here. Let's go to a screen share, and then we'll kind of see what's happening as it's going on and come back and check our results. So the water is rising up. It's kind of hitting the marker and carrying up some of the marker with it, at least in some cases, not so much in other cases. And we're going to take a closer look at that in a bit. I'm going to go to a screen share, and I'm going to look at our lab. And this one is called the paper chromatography lab. And really, probably the big thing with chromatography, we're trying to separate things based on boiling point. No, that's distillation. Based on different IMFs, yes. Okay, and we're looking at a couple of different things. Okay, let's maybe look at our materials. We had these strips of filter paper, which look like this. And I had some plastic cups, which we saw at the beginning, and then watch glasses we're just covering. So keeping all that vapor in there. And then we had analyte markers. The analyte is what was the dots we put on. And that's the thing that's going to rise up the paper column. I had Mr. Sketch markers, a black and a green one. Okay, and then I had some Sharpies, again, a black and a green Sharpie right there. Okay, and then I had 2 different solvents, water and acetone. So we're looking at the properties of those 2 different solvents, water and acetone, and then we're looking at the different properties of primarily Mr. Sketch versus a Sharpie. Okay, and then with the different colors, we might see just some other things, what components make up those colors, which is kind of an interesting addition. So looking at the procedure, this is what you do. You label your cups, you go through things, you can follow through this. You're getting your strips of paper. So I'll kind of skip ahead and show what I did. I took this and I made these papers. So BS is black Sharpie, GS is green Sharpie, okay? BM, contrary to what you might have heard in the past, is going to be black Mr. Sketch, and GM would be green Mr. Sketch. Okay, so we have these different combinations in either acetone or water. And if you go back to fill in the data table, you're going to see that you have all these different combinations. I didn't put a mystery marker in, so you don't have to worry about that right there. But kind of getting that prepared, putting the dots on, I go through all those different steps, and then I kind of showed you the last step where I actually put them in the solvent, and then we just watch it rise up the paper in doing that. All right, So let's take a look at what you're going to need to do. You're going to ultimately find a retention factor, and we'll kind of we'll show this in a little bit, how that's going to work. We're going to look at the distance that the analyte, which would be the Sharpie marker, went up, and compare that to the distance of the solvent. If they both went up the same amount, then your retention factor, it's a decimal, it would be 1.0. If the analyte did not move at all, it would be 0.0. If it moved halfway as far as the solvent, it's going to be 0.5. Okay, so that's what you're going to be doing. And I think an estimate to the nearest tenth is about all you're going to be able to get with the things that we have here. So you can look at the distance of the solvent, distance of the analyte, and then figure out a retention factor. Okay, and the analyte can't go farther than the solvent because it travels with the solvent, or if it's more attracted to the paper and less to the solvent, it won't go as far. Okay, so let's look at some other things that you're going to be doing in this lab. And you have some pre-lab questions, just talking about this and working with it. And again, you have a mobile phase, which would be either the acetone or water. And then the stationary phase is the paper. All right. So you're going to be talking about those things in there. And then there's some questions about delta H1. Remember delta H2, delta H3, solute, 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 solvent, solvent, and solute, solvent, and forces there, and explaining what you're going to be seeing. And then there is some just general conclusion questions. I did throw on an application question, kind of an old AP question, just to see how well you can do with this concept right here. So that's what you're going to be completing and working with. And I think I'm going to have you do this, or you can work with it, certainly talk with others about it, but this is your instruction for it. And then I think I have it one day where I'll do Q&A and kind of go through this and help you with this, at least leave you that option to do this. All right, let's go back and maybe take a look at what we are seeing. And let's go take a look. I'm going to go to a different screen share if I can find this. Go here, share, and this is going to be what you have. Now, if you look real closely, you can see they're labeled kind of in the same order. BS, GS for water, BS, GS for acetone. Okay, so I'm looking at it, it looks like it's traveling a lot further in the acetone than the water. Okay, and then BM, GM for water, and BM, GM for acetone right here. Okay, for all of these, it almost looks like it's having the water and the color is going about up to the top. So it looks like you're gonna have retention factors close to 1, except here. It's hard to see the water edge. You might be able to see it. Assume the water edge goes about to here, about the same distance as right here. And then you can compare it to how far this travels to get a retention factor for that. So looking at this will probably have pretty low retention factors, where other ones will be relatively high on that scale. So I do have that document in Schoology, so make sure to look at that. And that will be your data for this. Let's just go back to what we saw with our results. And let's see, I'm going to go back, actually. I'm going to end my share, I believe. I'm going to reposition this, and let's see what's going on inside our containers. So we can see a little bit of movement with some of these things. Okay, I kind of got the order of these wrong, I realize. Let's see, so I kind of put these backwards. I have the black Mr. sketch here and the green Mr. sketch right here. Okay, and then I have the black, and this is an acetone, and then the black Sharpie and green Sharpie and water. So it's a little different order than you saw, which I'm not seeing much movement here, seeing a lot of movement here. This would be the black Mr. sketch here and the green Mr. sketch here. And this would be the black Mr. sketch, and this is in water. And then, I'm sorry, this would be acetone, and then this would be water again. Okay, so we got the water and the black and green Mr. sketches here. We got the acetone black Mr. sketch and green Mr. sketch here, and then we have the Sharpies in water and in acetone. Again, you don't have to go by the data here. I would look at the one on those charts, but it probably will be pretty similar. But I think by looking at that specific one, you can actually take it and measure, will be a lot easier. I just wanted to show you that process. Notice some of them went up to the top already, and looks like it was probably about, what, 15 minutes, 10 minutes for that to occur. All right, I think I'm going to end here. And thanks for watching, and let me know what questions you have. Thank you.